data comes from catalog, like density, weight per unit, or weight per unit length. These are stored in the relevant catalogs. For equipment, the data has to be entered by user. So this is how it is. So let's just discuss the weight data, the theory around it, and then we'll see the practical also. So the piping, HVAC and cable tray, these three things, the weight data has to be stored again individual component. So every component inside piping, cable tray and HVAC has a specification reference, and for each specification reference you set weights against those components. For example, elbow of schedule 80 and bore say 4-inch has weight around 5.6 kg per unit, or maybe I'm just giving an example, it may be maybe around 40 or 60. So that is stored in catalog, right? For piping, the wet weight also can be calculated. In that case, the fluid reference, like fluid properties, can be defined inside catalog, uh, and the fluid reference is set through fluoref attribute on the piping and branch elements. So again, that's a catalog property. For equipment and volume models, which is a soft type of, again, equipment only, and sub volume model, the weight data is stored in following attributes in the design model itself. User weight, the dry weight of the element, a fixed value or an expression can be used. User wet weight against the wet weight of the element, dry weight plus any fluids. Okay. User center of gravity, the coordinates of the dry center of gravity from the element's origin. So from the element origin, means the equipment origin, what is the coordinate of center of gravity for the dry element without any fluid? Similarly, the user wet center of gravity, so the coordinate of wet center of gravity, that is dry plus fluid along the fluid from the element's origin. Fine. A value expressed must be entered on for each attribute on each element after it has been created. For structural elements and their soft types, the weight data is obtained by multiplying the volume. So for structural elements specifically, the weight data is obtained by multiplying the volume by the density of the assigned material. Okay, sorry. Okay. Fine. This is how structural for weight is calculated for piping and HVAC and cable tray. The weight per unit element is stored in catalog. Okay. So center of gravity data for piping, HVAC, cable tray. The center of position is taken from P point catalog. So again, center of gravity for each component is defined in the catalog, and the purpose is set to COFG for that P point. So need not to go in detail because this is catalog part. For equipment, I already told you there are few attributes on equipment: user center of gravity, user wet center of gravity, which stores the data. Okay. So accuracy of on what factors the accuracy of the mass property is different. It depends on arc tolerance and mass arc tolerance. So uh, some values like volume uh, or surface area around the curved surfaces like nozzles or any circular geometries, it depends on the arc tolerance. I told you yesterday this setting, view, graphics, representation, arc tolerance and mass arc tolerance. So this can be set to some value so that the circles appears a little smoother. If I make it holes drawn or flange hole drawn, the holes are not perfect circles. So in order to Okay, the units are actually 0.001. So let me change the unit to millimeter to make it more clear. Project options, units, millimeter, save, and come back to view, graphics. So arc tolerance by default is 1. If I make it 0.1, so the circle appear better, more smoother. So definitely when the volume is calculated, these circular volumes, the whole volumes is excluded from that. So accuracy of the data will depend on the arc tolerance and mass arc tolerance also. This can be set to, so this both these values are calculated, used in calculation of data, this mass properties data. Okay, tolerance, you can just quickly read it. Number of faceted edges. So it is all related to the faceted edges, which is become more smoother with the decreasing arc tolerance. That's why the value might be slightly different than higher arc tolerance. But increasing this value will slow down the decreasing the value of arc tolerance will slow down the performance. So it should be kept 0.1 only when you are calculating mass properties or doing graphic centric operations. Okay, weight and center of gravity. So let's take a quick example given at so pipe rack, they are calculating uh, weight and center of gravity. You can check out at page number 56 using the mass property utility. So there's a structure called pipe rack. We are assigning some materials to that. So when you study a structural module, you will see how you can assign different materials to the steel, and that material contains some density. So let me add first pipe rack here. I will remove all alt VVE. I will type here pipe rack, add it to the draw list. What's this? Delete this. I think this is okay. So individual column, beam, bracing can be assigned some materials, but if you want to assign it in a bulk, you can put a window around, right? There are 41 elements. If you go specification, material. So this material list is made in catalog. So here we have to assign S275 JR steel. I think let's check the manual. S355J0. Okay, this steel. So all sections are assigned. So, okay, what happened to this? Okay, they were already having this material, so they didn't change to bold font. Okay, 1 minute. So once we have assigned the material, the density of that material will be multiplied by the volume of the this individual beams and columns, and a value will be obtained for the